Every year, hundreds of millions to billions of incense sticks are dyed red, covering entire traditional craft villages and forming a spiritual symbol that connects the living with their ancestors. Yet elsewhere, some forms of incense are refined to the point that they no longer require a bamboo core. Certain varieties made from premium agarwood can reach prices of tens of thousands of dollars per kilogram, more valuable than solid gold. How can something as small as an incense stick create a global industry worth billions of dollars? In Vietnam, from raw bamboo and vo stalks, billions of incense cores are produced by the persistent hands of artisans, becoming an indispensable spiritual offering on ancestral altars. Meanwhile, in Japan, blocks of agarwood are meticulously refined at the highest level of craftsmanship, transforming nature's rare essence into coreless incense sticks that preserve the most authentic layers of fragrance. Today, join Agriculture Insight as we explore the world's largest incense production centers, where rising smoke is not only a cultural symbol, but also the result of a sophisticated transnational agricultural and logistics value chain. Incense is an ancient tradition of Asia, yet the strongest growth momentum of this industry is now coming from North America and Europe, where incense has become a familiar part of yoga, meditation, and modern wellness culture. This wave of consumption is pushing the global incense market toward the $5 billion mark in less than a decade. If Vietnam is the world's largest exporter of incense sticks, once accounting for nearly 90% of India's imports at its peak, then India remains the largest producer and consumer of incense on the planet. Each year, the country produces hundreds of thousands of tons of incense and provides employment for more than 2 million workers, most of them women in rural communities. Many people assume incense is merely a cheap, everyday item, but that perception quickly changes when Kiara is mentioned, the most expensive form of agarwood in the world, which can reach prices of up to 15,000 USD per kilogram, sometimes exceeding the value of pure gold. However, Kiara is almost a miracle of nature. It forms only when centuries-old agarwood trees become infected by specific fungi over extremely long periods, with an estimated natural occurrence rate of just 1 in a million. So how are the incense sticks that are lit every day in millions of homes and temples actually made? Let's begin the journey to uncover how incense is produced, the part we have all been waiting for. In Vietnam, around 80 to 100 traditional incense-making villages are still operating across the country, forming a vast production network that supplies billions of incense sticks to the global market every year. In the craft village of Lê Minh Xuân, considered one of the largest incense-producing hubs in the country, a single worker can produce up to 130,000 incense sticks per day, a remarkable scale for a traditional craft that has existed for centuries. Every incense stick begins with one of Asia's most familiar natural materials, bamboo. In Vietnam, the bamboo selected for incense production is typically between 3 and 5 years old, the stage at which the fiber structure has fully stabilized. At this point, the bamboo is strong enough to maintain the shape of the incense stick, yet still flexible enough to be split into thin cores without breaking. After harvesting, the bamboo culms are cut into sections and split lengthwise along the grain. This step requires extremely high precision, because even a slight deviation in the splitting line can cause the entire piece to crack along the grain and become unusable. From these larger bamboo sections, artisans continue splitting the material into thin strips. The strips are then bundled into large batches and transported to shaving workshops, where millions of incense cores are produced every day. Today, most production facilities rely on automatic shaving machines. Bamboo strips are fed into the machine, where ultra-thin steel blades continuously shave away the rough wood surface, transforming them into perfectly round sticks in seconds. Thanks to high-speed rotating blades, a single machine can produce around 30,000 to 40,000 sticks per hour, roughly equivalent to the output of about 20 manual workers who would otherwise have to carve each stick by hand, a process that is both labor-intensive and prone to painful bamboo splinters. After shaping, the sticks pass through a polishing machine where fine grinding wheels remove any remaining wood fibers. The result is a smooth and uniform surface, a crucial condition for allowing the incense powder to firmly adhere to the bamboo core later in the process. However, even after shaving, bamboo sticks still retain a certain amount of natural moisture within the wood. For this reason, they must be dried under the sun for about 1 to 2 days to completely release the remaining moisture. If the sticks do not reach the proper dryness level, the finished incense may burn unevenly or extinguish halfway through, a technical flaw considered unacceptable in many spiritual rituals. After being completely dried, the bamboo sticks move to the stage that gives incense its familiar appearance, dyeing the base of the sticks. Thousands of sticks are tightly bundled together and dipped into tanks of red or lotus pink dye. Only the bottom 4 to 6 centimeters of each stick, out of a total length of nearly 40 centimeters, are colored, creating a clear visual marker without affecting the upper section that will later be coated with incense powder. The dye solution is made by dissolving pigments in water with a small amount of adhesive, allowing the color to firmly bond to the bamboo fibers and retain its shade even after days of sun drying or long-distance transportation. In many craft villages, this task is often carried out by men, as each bundle can weigh 4 to 5 kilograms and must be repeatedly dipped and swung to ensure the dye penetrates evenly between thousands of sticks. Beyond its technical purpose, the colored base also carries cultural meaning. Lotus pink recalls Vietnam's national flower, while red symbolizes luck and sincerity in spiritual rituals and ancestral worship. After dyeing, the bundles of bamboo sticks are brought out to the yard and spread into large circular patterns, a familiar sight in many incense-making villages. At first glance, the arrangement looks like a vibrant decorative display, but it is actually a crucial drying technique. Each circle can hold about 3,000 to 5,000 sticks, arranged radially from the center so sunlight can reach the entire bundle at once. The gaps between the sticks allow air to circulate freely around each bamboo core, helping the dye dry quickly and evenly, while preventing warping or deformation after coloring. For this reason, incense production depends heavily on weather conditions. With strong sunlight, the sticks can dry in just 1 day. But during cloudy or rainy weather, the process may take 3 to 4 days, requiring workers to frequently turn the sticks to prevent moisture buildup and ensure the color dries evenly. But before bamboo sticks can become finished incense, another crucial component must be prepared: incense powder, the element that determines the fragrance of the stick. This powder is usually brown or golden brown, made from finely ground aromatic wood, blended with natural herbs. For the domestic market, the mixture is sometimes enriched with ingredients such as cinnamon, star anise, and various medicinal herbs. In some traditional recipes, it may even include up to 18 types of herbal ingredients, creating the warm and distinctive fragrance commonly associated with traditional incense. At this stage, the process moves to its most crucial step: rolling the incense, where the bamboo sticks and incense powder combine to form the finished shape of each stick. Workers pour the powder into the machine's tray and feed bundles of bamboo sticks into the rotating system. As the machine operates, the base of each stick is held firmly while the body spins and rolls through the powder. Through this rotation and gentle pressure, the powder gradually adheres to the stick, forming an even coating. Within just a few seconds, the smooth bamboo sticks become finished incense sticks, with a powder layer about 1.5 to 2 millimeters thick and a length of 35 to 40 centimeters, a familiar size in many Asian households and temples. This simple mechanism has dramatically increased productivity. While manual methods once allowed a worker to roll only about 500 sticks per day, machine-assisted production can reach up to 50,000 sticks in the same time. The incense sticks that come out of the machine are still slightly moist, so they must undergo a final drying stage until the incense powder is completely dry and firmly bonded to the bamboo core. Once they reach the required dryness, the sticks are bundled into dozens or larger batches and moved to the packaging stage. In many modern workshops, each bundle is also labeled with a barcode for traceability, completing the final step that transforms a traditional craft product into a standardized commercial good, ready to leave the workshop and release its fragrance in temples or on ancestral altars during important occasions. Unlike in Vietnam, where incense sticks are made from a bamboo core coated with aromatic powder, in Japan, the entire stick is pressed directly from incense materials, with no core at all. Ingredients such as sandalwood, cinnamon, clove, and agarwood are ground into a fine powder of about 20 to 50 microns, then mixed with taboo powder, a natural binder extracted from the bark of the machilas tree. In traditional formulas, taboo typically makes up about 10% of the mixture, providing enough binding strength while preserving the natural aroma of the woods. After being measured in precise proportions, the entire mixture is transferred into a large mixing tank. Here, 2 heavy grinding wheels rotate slowly, continuously pressing, kneading, and blending the powder with water until the material reaches a clay-like consistency. This process typically lasts 30 to 60 minutes, allowing water to penetrate evenly into every particle, while the moisture level is maintained at around 25%, an ideal balance that ensures the mixture is cohesive enough to bind together, yet soft enough to pass through the extrusion mold. Because it is made entirely from natural aromatic wood powder, Japanese-style incense sticks usually develop a distinct brown or dark brown color after shaping, unlike the bright red base commonly seen in bamboo core incense across many parts of Asia. In some modern production lines, the mixture may also be given a light blue tint to help differentiate fragrance formulas and facilitate process control before being extruded into the coreless incense sticks characteristic of Japan. When the mixture reaches its ideal pliable consistency, the process moves to the most critical stage, incense extrusion. The material is fed into a hydraulic press fitted with a metal die plate containing about 200 to 300 tiny holes, each forming one incense stick. As the piston compresses, the entire mass is pushed through the die simultaneously, quickly producing hundreds of thin, straight incense strands. Unlike Vietnamese incense, which relies on a bamboo core to maintain its shape, Japanese incense must hold its structure entirely through the body of the incense itself. For this reason, parameters such as the diameter of the die holes, piston pressure, and the fineness and moisture content of the mixture must be precisely controlled. Through this mechanism, a single batch of paste can produce 200 to 300 incense sticks at once, each about 2 to 3 millimeters thick, yet still straight and strong enough for the next stages of production. Immediately after leaving the extrusion mold, the incense strands are still very soft, almost like pliable clay, making them easy to bend or break if separated individually. For this reason, they are kept together as a single sheet and laid flat to stabilize the structure, allowing pressure to distribute evenly across the surface and minimizing deformation. Once the surface begins to firm up, artisans use a sharp circular blade that rolls along a guiding rail to cut the sheet. Thanks to the blade's rolling motion, the cutting force is directed downward rather than sideways, allowing the entire sheet of incense to be sliced cleanly in a single pass with almost no displacement of the strands. Using this method, hundreds of incense sticks can be cut simultaneously to a standard length of about 13 to 15 centimeters, with a tolerance of less than 1 millimeter. The level of precision needed to ensure the sticks burn steadily and evenly during use. However, even after reaching their final size, the incense bodies are still not fully stable. The remaining moisture in the mixture requires them to undergo a drying stage before packaging. The sheets of incense are placed on multi-tier wooden racks, where each strand is kept straight and stable in an environment of around 25 degrees Celsius for up to 48 hours. With continuous air circulation, moisture gradually evaporates from the incense body, allowing the structure of the aromatic powder to shrink evenly, a key factor that enables each stick to burn steadily for about 20 to 30 minutes, depending on its length. Finally, once the incense sticks are completely dry, workers gather them into small bundles and carefully align them by hand so that the sticks lie perfectly parallel. Each bundle typically contains 30 to 50 sticks and is secured with a thin strip of paper wrapped around the middle to maintain the structure and protect the incense surface during transportation. The bundles then undergo a final inspection, where any sticks that are bent, broken, or uneven in color are removed before being packed into tubes or paper boxes decorated with traditional patterns. A finished bundle of Japanese incense is characterized by perfectly straight sticks, flat cut ends, and nearly uniform color. This precision reflects the distinctive craftsmanship philosophy of Japanese incense making, where a high-quality box of incense may cost $20 to $100. Offering in return a clean, delicate stream of smoke, a long and tidy ash line, and a fragrance that spreads softly and deeply without being harsh or heavy. Now, let us explore one of the world's leading sisal-producing countries. In northern Tanzania, around the regions of Tanga and Morogoro, where rainfall lasts for only 3 to 4 months a year, sisal has not merely survived, but has dominated the agricultural landscape for more than a century. Sisal is typically planted at the beginning of the rainy season in March on gently sloping land where water does not stagnate, yet retains enough moisture for young plants to establish themselves. Seedlings are planted directly into the soil, spaced at approximately 1 meter apart, allowing their long, thick leaves to develop to full capacity. During the first 2 to 3 years, sisal requires very little intensive care. Thanks to a root system that penetrates several meters deep and a natural water storage mechanism within its leaves, the plant can thrive with annual rainfall of around 700 millimeters, significantly lower than that required by most industrial crops. It is precisely this paradox, minimal care combined with long-term productivity, that makes sisal an ideal crop for semi-arid agricultural regions. Have you ever noticed how sisal looks remarkably similar to a plant commonly used to make spirits? In fact, sisal belongs to the same agave family as the plants used to produce tequila and mezcal. However, while agave grown for spirits is cultivated to harvest the sugar-rich core at its center, sisal follows an entirely different path. It is grown to extract fiber from its leaves. This fundamental difference shapes every aspect of how sisal is cultivated and harvested. After approximately 3 years of growth, sisal enters its harvesting phase. The plant is not cut down. Instead, it is harvested repeatedly in cycles, a process that can continue for nearly 10 years. During each harvest, workers cut only the outer, mature leaves, where fiber concentration is at its highest. The central core and young inner leaves are left intact, allowing the plant to continue growing. Sisal leaves are cut close to the base using specialized knives. A harvest-ready leaf is typically over 1 meter long, thick and rigid, and heavy with moisture. requiring a firm, decisive cut to avoid damaging the fibers inside. Over its lifetime, a single sisal plant can produce more than 200 leaves, though only a portion is taken during each harvest to prevent exhausting the plant. Once cut, the leaves are laid out directly in the field, where overly young or damaged leaves are removed. Leaves that meet quality standards are then bundled uniformly, prepared for the next stage of the production chain. On average, a single worker can harvest more than 1 ton of sisal leaves per day. And on large plantations, total daily harvests can reach tens of tons. When sisal leaves enter the factory, the fiber extraction process begins immediately and runs continuously. The leaves are placed parallel on a conveyor belt, with their tips directed toward a set of pressing rollers that use mechanical force to keep them straight and stable. The conveyor then feeds the leaves into the decortication machine, where high-speed rotating drums crush the leaf pulp and separate the long fibers inside. The pulp and plant juice are expelled at the decortication chamber, while the raw fibers continue forward, retaining their full length. A standard production line can process 20 tons of leaves per hour, yet the output is highly selective. Only about 4% of the leaf's weight becomes usable fiber. The raw fibers then pass through a continuous washing system to remove sap and plant residues, before undergoing preliminary combing to separate and straighten the strands. Within just a few minutes, a fresh green leaf is transformed into raw fibers, ready for the next stages of processing. After washing and preliminary combing, sisal fibers enter the drying stage, a critical step that determines both color and durability. The fibers are spread out or hung evenly on drying racks, ensuring they do not overlap so moisture can evaporate uniformly. In major production regions such as Tanzania and Brazil, sisal is typically sun-dried, where ambient temperatures average around 30 to 35 degrees Celsius. The drying process usually lasts 2 to 3 days, until the moisture content of the fibers drops below 12%, a safe level for storage and further processing. If drying is insufficient, the fibers may darken, lose strength, and become more susceptible to mold. After drying to the required standard, sisal fibers are collected directly at the drying yard, the moment when the fiber's final form first becomes clearly visible. The fibers are removed from the racks and carefully recombed to eliminate short strands, sand, and remaining impurities. They are then graded by length, color, and uniformity. From over 1 ton of fresh leaves, only around 40 kilograms of usable fiber remain, bundled into 20 to 25 kilogram bales. This is the critical stage where raw mass is refined into true value. After being delivered to the factory, sisal fibers are fed into an industrial rotary drum combing machine to clean and even out the fibers. Inside the machine, steel rollers fitted with metal teeth rotate continuously at a speed of approximately 400 revolutions per minute, pulling and aligning the fibers in a fixed direction. This process straightens the fibers, separates tangled bundles, and removes short fibers and residual debris. The spacing between the rollers is precisely calibrated to just a few millimeters, sufficient to clean the fibers thoroughly without breaking the long strands. Immediately after combing, the sisal fibers are transferred directly to a hydraulic baling press. Here, the fibers are compressed into standard bales weighing approximately 25 kilograms, reducing volume and stabilizing their shape. The baling stage marks the end of fiber processing within the factory, transforming loose sisal fibers into a complete raw material unit ready for the next stage of spinning. At the spinning mill, sisal fiber is not fed directly into the twisting process. The first step is fiber alignment. Bundles of fiber are separated, stretched, and arranged parallel along a single axis. This step eliminates the natural misalignment of plant fibers, the primary cause of fiber breakage if twisting begins too early. Once the fibers are aligned in the same direction, primary twisting begins. At this stage, the fibers are lightly twisted at a density of around 100 twists per meter, just enough to form a stable single yarn. The goal is not strength, but to prevent the fiber from separating during further processing. Next, the single yarns are plied and subjected to secondary twisting. Depending on the intended application, sisal may be spun into 2-ply or 3-ply yarns. Increased twist density locks the fibers tightly together, creating a structure capable of bearing load and resisting abrasion. Even a small deviation in twist level can reduce the fiber's service life in real-world use by up to 40%. At the end of the spinning process, sisal yarn is twist set and strength tested, then graded and sent on to subsequent stages, most commonly rope making. And now, sisal yarn enters the rope making stage, where a single strand is transformed into a fully load-bearing structure. The process begins with strand assembling. Multiple spun yarns are fed in parallel into the machine and held under controlled tension before moving into the next twisting phase. This is followed by cable twisting. The strands are twisted in the opposite direction of the original spin, balancing internal forces and preventing the rope from unwinding under load. Depending on the design, sisal ropes typically consist of 3 strands, each made up of dozens of finer yarns. This multi-layered structure allows the rope to distribute stress evenly and improves resistance to abrasion during use. Once the required twist is achieved, the rope is set and continuously straightened over lengths of up to 200 meters in a single production run. Even minor deviations during twisting can create localized weak points. For this reason, finished ropes undergo load testing with tensile strength capable of exceeding 1 ton before being cut, coiled, and packaged. At this point, sisal completes its journey from a plant-based fiber to a reliable load-bearing tool used across everyday life and industry. The journey of lotus fiber follows a completely different path, more meticulous, more labor-intensive, and far more delicate. Lotus stems are typically harvested between May and August, when the plant is at its peak growth and the fiber content inside the stem is at its optimal condition. The ideal time for harvesting is early in the morning, when the stems are still fresh, rich in natural sap, and have not yet been dried by the sun. If harvested at midday or in the afternoon, the fibers inside quickly lose their elasticity, making them extremely difficult to extract. After harvesting, the lotus stems are washed thoroughly before any further processing begins, in order to remove mud and impurities, and to keep the stems fresh so the fibers are not damaged. The extraction of lotus fiber must be carried out within 6 hours after harvesting, while the lotus stems are still fresh and rich in natural sap. First, the stems are cut into short sections of about 20 centimeters, a length suitable for hand processing. Each section is then gently broken open, exposing the fine fibers hidden inside the stem. From each section, the artisan typically pulls out around 10 extremely delicate fibers, almost transparent and very easy to break. These fibers are too short to be used individually, so they are joined together by hand, lightly twisted between the fingertips to form a continuous thread. Throughout the process, the fibers are kept slightly damp with water, which helps maintain flexibility and prevents breakage. The entire operation is slow and entirely manual. On average, a skilled worker can extract about 200 meters of lotus fiber in a single day. If the stems dry out or the movements become too forceful, the fibers quickly become unusable. After spinning is completed, the lotus fiber enters the winding stage, the final step before weaving. At this stage, the fiber is guided through a winding machine to control both tension and direction. The machine keeps the fiber under just enough tension, preventing sagging, misalignment, or overlapping as it is wound. The winding process moves very slowly, as lotus fiber is extremely fine and fragile. Any sudden increase in tension can cause the fiber to break at its weakest point. During a stable run, the fiber can be wound continuously into a spool of approximately 150 meters, sufficient for use as warp yarn on a traditional loom. If the fiber is unevenly distributed, or the spool becomes misaligned, the entire roll cannot be used for weaving. For this reason, the artisan must constantly observe the process, adjusting the hand crank and machine speed. It is at this stage that loose lotus fibers are transformed into ordered spools, ready to enter the demanding process of lotus silk weaving. When the lotus yarn spools are ready, the process of weaving a lotus silk scarf begins with loom setup. The lotus yarn is stretched as warp threads on a traditional hand loom, one strand at a time, with tension carefully calibrated to keep the fabric surface even. If even a single thread is misaligned, the warp can break during weaving. During weaving, the artisan opens the heddles to separate the warp threads, passes the weft yarn through the opening, and then beats very gently to secure each row. Every movement is slow and deliberate, as lotus fiber is extremely fine and brittle. In a single working day, the weaver may need to stop hundreds of times to repair broken warp threads, something that rarely occurs when weaving silk from silkworms. Each repair requires precise tension, otherwise the fabric surface will be flawed. At this pace, completing one lotus silk scarf typically takes around 7 consecutive days, with less than 1 meter of fabric woven per day. This slow, high-risk process, entirely dependent on skilled craftsmanship, is what drives the price of a lotus silk scarf to between $300 and over $1,000 USD, making it a textile that is nearly impossible to mass produce. No holiday creates consumer and production pressure on the scale of Christmas. In the United States, within just the final weeks of the year, industries directly tied to the season, such as decorations and gifts, can generate up to 40% of their annual revenue, 2 to 3 times higher than Valentine's Day or Halloween. If the US and Europe function as massive engines for confectionery production, then China stands as the world's largest workshop for Christmas decorations. Most glass ornaments, snow globes, and fireworks are mass-produced early in the year, stored for months, and only truly consumed during the final weeks of December, generating tens of billions of dollars globally each year. It is from this system that millions of familiar Christmas products are completed long in advance within modern factories and production facilities, turning Christmas into the ultimate destination of an entire industrial supply chain built around the most important holiday of the year. The process begins as a glass rod is heated in a gas flame at temperatures of around 1,900 to 2,000 Fahrenheit, high enough to break down its rigid structure and shift the material into a glowing, pliable state, flowing like molten honey. During this stage, the craftsman continuously rotates the blowpipe to distribute heat evenly and keep the glass stable. While the glass is still alive and tacky, the heated mass is quickly rolled through finely crushed glass powder, essentially colored glass in microscopic granular form. It is then returned to the furnace for 30 to 60 seconds, allowing the powder to melt and fuse with the surface, locking color directly into the glass structure. At this stage, shaping does not follow a single fixed method. Depending on the craftsman's skill and habit, the form may be refined using molds or adjusted directly with specialized tools such as tongs and shears. While the glass remains glowing and sufficiently pliable, these actions typically take place within 10 to 20 seconds, the brief window before the material begins to cool and stiffen. Each gentle squeeze or precise cut is used to control thickness, surface ridges, and overall proportions, where even a minor misstep can cause the form to shift under the combined effects of heat and gravity. In some workshops, glassmakers create the initial sphere by heating the middle of a glass rod directly and blowing air to expand the material into a hollow, preliminary form. This method typically takes 20 to 30 seconds, making it well suited for smooth ornaments and high-volume production. By contrast, the process of forming a separate glass mass, then reheating it, rolling it in colored glass powder, and firing it again can take 2 to 3 times longer, but allows for greater control over color and surface effects. These two techniques do not replace one another. They are used flexibly depending on design requirements and the technical traditions of each workshop. Once the shape is complete, a glass ornament is still nothing more than a transparent sphere. Its familiar sparkle only appears during the silvering stage. The ornaments are gathered into clusters and placed into a silvering bath, where a chemical reaction coats the inner surface with a metallic layer only about 0.1 micron thick, nearly 1,000 times thinner than a human hair. The craftsman continuously rotates the cluster to ensure the silver spreads evenly without streaks or dead spots. The reaction is then stopped, and any remaining solution is collected for reuse. Remarkably, less than 1 gram of silver can be enough to coat dozens of ornaments, yet this ultra-thin layer is what ultimately determines their reflectivity and visual impact. For each design, craftsmen cannot rely on machines, but must paint and decorate every detail by hand across the continuously curved surface of the ornament. A deviation of just a few millimeters can throw the entire composition off balance. While the paint is still wet, glitter is applied manually so it bonds directly to the surface. One ornament can hold tens of thousands of microscopic particles, small enough to adhere securely, yet numerous enough to scatter light in every direction. To achieve this effect, many workshops blend glitter in 5 to 7 different particle sizes, ensuring that each gentle turn under the lights produces a constantly shifting, non-repetitive play of reflections. To conclude the meticulous process, each ornament is placed into a molded tray for stabilization and layered with thin protective paper to prevent scratches. The pallets are then fully wrapped and prepared for long-distance transport. Each pallet can carry up to 2,000 pieces, shipped out simultaneously to meet the enormous decorative demand of millions of Christmas trees during the busiest holiday season of the year. There is an interesting fact about glass ornaments. In 16th to 17th century Europe, people originally decorated Christmas trees with real fruit, especially apples, as symbols of abundance and prosperity. As glassmaking advanced, glass ornaments emerged as a more durable and luminous version of fruit, reflecting candlelight and early lamps, making Christmas trees appear to glow through the long winter nights. From that point on, glass ornaments became the central symbol of the Christmas tree, representing light, life, and hope in the depths of winter. Both are spherical in form, but while a glass ornament shines in stillness, a snow globe is the result of compressing an entire winter into a space defined by motion. The journey of creating a snow globe begins with casting and refining the decorative figures, the central core, where every small detail must be sharp and well-balanced. Before actual casting, the composition and proportions are developed using 3D models to prevent issues such as overly thin elements or parts that may break. Because when the globe is shaken, the internal core can experience oscillating forces equivalent to up to 500 grams, applied repeatedly from multiple directions. If the design is flawed, delicate details can crack or break after only a few uses. The globe is then filled with purified water and infused with ultralight polymer snow particles, engineered with a density carefully calculated to be lighter than water. This allows the snow to remain suspended for around 30 seconds before settling, creating a slow, even, and visually pleasing snowfall effect. Only purified water, free of minerals and ions, can be used, as it does not react with the paints, adhesives, or polymers inside the globe. This prevents sediment buildup and preserves the signature snowfall effect over long periods of time. Born in the agave valleys of Jalisco, tequila quietly crossed borders, riding the wave of globalization to spread across the world. Each year, Mexico produces over 600 million liters, exporting to 120 countries. In the United States alone, its largest market, people consume more than half of the world's tequila, making it the second most popular spirit after whiskey. Unlike 3/4 of the world's liquors, which are distilled from grains, tequila has a truly unique origin. Born from the blue agave plant, a symbol of wildness and instinct, it was made to ignite the senses, bold, unfiltered, and full of character. But with an alcohol content of 35 to 55%, just a few shots are enough to scorch your throat and push your limits. At the beginning of the journey, roasting in stone ovens is the most iconic step in the traditional tequila making process. Workers dig deep, cone-shaped pits into the ground, line the bottom with volcanic rocks, then burn wood for hours until the heat spreads evenly throughout the pit. Once the temperature is just right, the piñas are stacked in layers, covered with dry agave leaves, fibers, and soil, creating a natural underground oven. Most artisanal brands, such as Grand Patron Smoky or Siembra Valles Ancestral, slow roast the hearts for 5 to 7 days, allowing the starches to gradually convert into sugars while absorbing the smoky, woody, and mineral aromas. This slow transformation infuses the agave with deep notes of caramel, smoke, and earth, a signature richness that no industrial steel oven could ever replicate. After roasting, the surface of each piña turns a gleaming amber hue, while the flesh inside becomes soft, aromatic, and sweet. They are left to cool naturally for several hours, allowing steam to escape and the fibers to relax. Once the temperature stabilizes, workers use hand-forged steel axes to chop the massive piñas, each weighing up to 100 kilograms, into smaller pieces. Each strike is not just an act of strength and precision, but the first true step in transforming the piña into tequila. The chopped pieces are then gathered and left to breathe for a few more hours before moving on to the next stage of conversion. At this stage, the roasted agave is taken to a traditional stone mill pit, where a massive tahona wheel, weighing nearly 2 tons, slowly rolls over each batch of softened fibers. In the past, this stone wheel was pulled by donkeys or oxen, but today it is mostly powered by slow-turning motors that preserve the rhythm of traditional milling. As the tahona rotates, a worker stands nearby, using a rake to turn, spread, and guide the agave pulp back into the wheel's path, ensuring every strand of piña is thoroughly crushed but never pulverized. The tahona doesn't just extract the sweet juice, it also retains part of the fibrous pulp, an element that gives the tequila a fuller body, natural smokiness, and a deep, lingering finish. The honey-like liquid collected from this process, called aguamiel, carries all the sugars, minerals, and aromatic compounds of the agave. This sweet nectar then flows through a network of pipes into large fermentation tanks, ready for the next transformation. The traditional method is still preserved today, but as global demand continues to rise, producers have had to adopt modern production lines, both to reduce manual labor and to maximize output. That's why our journey now takes us to large-scale tequila distilleries, where hundreds of millions of bottles are produced each year to supply markets across the world. Unlike the artisanal process, in modern facilities, the agave hearts are simply split in half before cooking. This task is still done manually. Workers wield large axes or machetes to cut through the tough cores, allowing the piñas, each weighing tens of kilograms, to steam more evenly in industrial ovens. Every decisive strike not only paves the way for mechanized processing, but also preserves the human touch, a lasting mark in the journey of creating tequila. Right after being chopped, the piña pieces are placed onto steel conveyors and carried into massive steam chambers. Inside, steam is pumped in at a pressure of around 1-2 bar, maintaining heat for many consecutive hours. This method allows the starches within the agave core to convert into natural sugars much faster than in traditional brick ovens. However, the trade-off is a cleaner but lighter flavor, lacking the distinctive smoky caramel notes once imparted by fire and volcanic stone. After cooking, the piñas are crushed to extract the agua meal. In this stage, mechanical milling systems equipped with continuously rotating steel rollers both press and spray spring water over the fibers to fully extract the remaining sugars and aromas from the agave pulp. This method achieves up to 98% sugar extraction efficiency, making it ideal for large-scale industrial production. However, it also removes much of the natural oils and fibers. For that reason, many modern producers still preserve part of the tahona process alongside, to retain the depth of flavor and the artisanal character that define traditional tequila. At the fermentation stage, both the juice and the remaining fibers are poured into large steel tanks. The crushing process takes about 2 hours to extract all the liquid. From there, the resulting mixture is piped into huge wooden vats, where yeast is added, allowing the sugars to begin their transformation into alcohol. The yeast multiplies rapidly, consuming all available sugars and producing alcohol along with CO2. Within about 30 hours, most of the sugar has been converted into alcohol, and after 72 hours of fermentation, the mixture develops a slightly sour taste and fills the air with a rich, distinctive aroma. Immediately after fermentation, the liquid is transferred into distillation stills to separate the alcohol and remove impurities. The first distillation produces a crude spirit called ordinario, with an alcohol content of about 20 to 25%. It is then distilled a second time to refine and raise the strength to between 38% and 55%. Traditional copper stills lend warmth, complexity, and a classic aroma to the tequila, while stainless steel stills in industrial production ensure precise control and higher efficiency. This is the pivotal stage where the spirit's strength and layers of flavor are defined. Afterward, the tequila is transported by tanker trucks to aging warehouses. There, in vast cellars, more than 9,000 American white oak barrels are kept under a fine misting system to maintain humidity and prevent evaporation. The finest tequilas are aged for up to 5 years, absorbing the essence of the wood and developing a superb depth of flavor. For more complex varieties, the tequila is aged for at least 2 months or longer, depending on its quality. During this maturation, it draws in the wood's character, acquiring its signature amber color and rich, rounded taste. And after all those transformations, the final spirit is ready for bottling. But first, it must pass a meticulous quality check through tasting. Once approved, the tequila is sent to the bottling line, where each bottle is placed upside down on a conveyor and rinsed with tequila itself to eliminate any trace of impurities. After one last quality inspection, every bottle is individually numbered, allowing it to be traced back to the exact distillery where it was made. Each year, This facility ships out up to 420,000 barrels of tequila, distributed to markets across the globe. If you ever have the chance, visit the state of Jalisco, because nothing compares to standing amid endless agave fields, breathing in their distinctive aroma, and feeling the spirit of Mexico all around you. Here, tequila is more than just a drink. It's a living culture, flowing through family-run distilleries, bustling markets, lively street bars, and the free-spirited people themselves. Together they form the pure essence of Mexico, a place where every color, sound, and flavor intertwines to tell one timeless story, the story of tequila.